Hi everyone. Today we're going to be talking about evaluating functions. Evaluating functions. You have evaluated for quite some time. When you evaluate, remember you just take the value for the variable and plug it in to solve. So here we're actually going to plug in or substitute in a variable expression, very similar to what you were doing with solving systems when you solve by substitution. So here we're going to evaluate, so we want to find y when x is 3m. So we're just going to leave a space for whatever x is, and then come back and put what x is, 3m, and then simplify. So y equals, remember exponents before multiplication, so 5 times 3m squared is 9m squared. And then the 6 does not change, that stays constant. And then y equals 45m squared plus 6. So substituting in, evaluate just means substitute in and simplify. So filling in the table, we're trying to find, so this is our input, and we're trying to find our output and the ordered pair so we can have a set of relations. So when x is 2, we're going to plug 2 in for x, and we get that y is 8. When we plug 4 in for x, we get that y is 12. When we plug 5 in, we get 14. So, what are the ordered pairs? Well, here, when x was 2, y was 8. So that is your ordered pair. 4 and 12, 5 and 11. So evaluating functions is just like that, except we'll be using function notation. So what is function notation? Function notation is just an alternative way to write an equation that allows you to name different equations and values that are input into a function. So it's just a different way of writing it. So we're used to this being a y, but with function notation it looks like this, where this x is still going to be your independent variable. It's going to be your independent variable, and this is the function name, and it is read f of x. So the function of x is this. Many times this is named with a different variable. We see g's and h's a lot. So it is just this, where we're used to seeing a y in function notation. It's just a different way to write it. So why do we need a different way? What is the purpose? What is the purpose of writing it in function notation? Well, function notation tells us that each member of the domain matches with exactly one range. So for it to be a function, remember every input can have only one output. So if it is a function, that holds true. We could have it as an equation, though, where it doesn't hold true. So for example, if the function was x squared, that would mean that for every x, there's only one y. Because if we put 2 in, 2 squared is 4, and only 4. If we put negative 2 in, it's still only 4. So there's more than one y, but for every x, there's only one y. Where here, y equals the positive and negative square root of x. This would not be a function because there are two answers. If we put let's do 4. If we put 4 in there, then y could be 2 or it could be -2. So the input 4 would get us to output, so it is not a function. So a second reason that we would write something in function notation, it allows us to give a relationship a name and distinguish it between different relationships. For example, here, we're saying that this function is x squared, this function is 3x, and this function is x plus 4. They're three very different relationships, where here we're saying y is this, but also y is this, and also y is this. So all the y's would be referring to the same x, where here our x's could be different. And if this is not making too much sense, it's okay. I just wanted you to see. You'll learn more about functions in years to come. I just wanted you to see this and learn how to evaluate. All right, to see if an equation shows a function, to see if it can be written in function notation, and we covered this a little bit earlier, all we have to do is plug in a number to see if we get two different answers. For example, if x is 2, y will be 4. So for every 2, we know it's going to be 4. So this is, yes, it's a function. For this one, though, if x is 4, so now I'm going to do y squared equals 4. I have to solve, remember, by taking the square root, by undoing that square. So y could be 2 or -2. So now when we input 4, we have two outputs. So no, this is not a function, because for every input, there is more than one output. So evaluating. Evaluating, again, just like we did in the warm-up, it just means to plug in. If you see find f of 9, that means for that independent variable, you are going to plug in 9. Anytime there's an x, you're going to plug in 9. That is it. So f of 9 would be 2 times 9 plus 6. So 18 plus 6 is 24. So f of 9 is 24. So now you can actually pull out that ordered pair for the relation. When x was 9, so the input 9, the output was 24. Or the domain was 9, the range was 24. So this goes back to exactly the same table that we had earlier, except I named it using function notation. So here I can plug in 2. So now the f of 2 equals 2 times 2 is 4 plus 4 is 8. So the ordered pair would be 2, 8. When I plug in 4, or input 4, 2 times 4 plus 4 is 12. So when I input 4, my output was 12. All right, here's some more practice. This is a little different because now instead of just inputting a number, we are going to input a variable expression. So many times it's a number, sometimes it's a variable expression. I want you to be exposed to both. So here we are going to input y plus 2 for our x. So I use parentheses. Anytime there's an x, I'm going to leave that open parentheses. And now I'm going to input y plus 2, and then simplify. So remember how to use the distributive property. So this goes back to distributive property and combining like terms. So 2y plus 4 plus y plus 2. Now I have to find my like terms. So 2y plus y is 3y, and 4 plus 2 is 6. So when I input y plus 2 into this function, I get 3y plus 6. All right, now let's input 3m to see what our output is. So again, I'm going to leave that parentheses. I'm going to input 3m squared. Remember to do the exponents first is 9m squared plus 6. So 45m squared plus 6. So the function when our input is 3m is 45m squared plus 6. Lastly, and you don't have this on there, I do also want you to be aware that you actually might be using two functions at once. Let's say, oops, I'll choose easy ones. F of x is 3x plus 2, and fg of x is 3 plus 6. 3 plus x. You might be asked to find something like, find the value of f when the function of g has an input of 2. So again, what this is saying is find the value of f for the value of g. So you are going to work in and go out. So here you're going to start with this. So find the value of g when the input is 2. And that would be 5. And then you're going to, so now you can think of this as find the value of the f function for the input of 5. So then you're going to come over here and use this one. So it's just getting used to this new way of writing things. All right, that's it. We out.